Question 8. Solve the following quadratic equation using the quadratic formula. A. Negative 2x squared plus 3x plus 1 equals to 0. Our quadratic formula requires A, B and C. A being negative 2, B being 3 and C being 1. If we put down the quadratic formula, we need to substitute in A, B and C. After which, we're looking to simplify this, so we'll have x equals to negative 3 plus or minus the square root of 9 plus 8, all divided by negative 4. 9 plus 8 is 17, so negative 3 plus or minus the square root of 17 is equal to negative 4. We can cancel out those negatives, leaving us with 3 plus or minus the square root of 17 divided by 4, which is our end solution. So we'll put a box around this. Marks wise, 3 marks. 1 will go to the method of using the quadratic formula, 1 will go towards correct working, and 1 will go towards the correct answer. Question 9. Solve the following equation by completing the square. The first step to complete the square is to rearrange your equation so that everything occurs onto one side of the equation. So 5x squared plus 10x plus 2 is equal to 0. Now you can't complete the square with an a value greater than 1, so we're going to remove the 5 as a common factor, leaving us with x squared plus 2x plus 2/5 equal to 0. The next step is to rewrite your question with x squared plus 2x, the same, but we're going to take that value of 2, divide it by 2, and square your result. We will add and subtract that, so 2 divided by 2 squared minus 2 divided by 2 squared. For 2/5 on the end, our c value will not change. This is still equal to 0. We can now take the first 3 values, x squared plus 2x and plus 2 on 2 squared, and factorize this down to x plus 2 on 2, or x plus 1 squared. This is a difference of perfect squares. The minus 2 on 2, or minus 1 squared, plus 2/5 won't change. We're going to combine together that negative 1 plus 2/5 to get negative 3/5, and now expand that 5 out, leaving us with a complete square, or an equation where we have completed the square of 5 bracket x plus 1 all squared minus 3. This is the complete square portion, but we have not yet solved. So to solve this, we're going to plus 3 to both sides, divide by 5, take the square root of that answer. Having a surd on the bottom of a fraction is poor mathematical notation, so this root 5 is something that we want to try to get rid of. And we can actually, it's a simple removal. If you multiply top and bottom both by root 5, the square roots on the bottom will cancel, and the top will become the square root of 15. That is mathematically more correct. You could indeed actually just put that into your calculator and get the same result. So if you put into your calculator root 3 divided by root 5, it will pop out with a solution of root 15 divided by 5. We're now going to plus 1 to both sides to give a result of negative 5 plus or minus root 15 divided by 5. That's my end result, so put a box around it. There's 1 mark for method, i.e. completing the square. There'll be a mark for solving, and there'll be a mark for getting your answer. Question 10. For each of the following equations, find the x-intercepts, y-intercept, turning point and sketch the graph of the equation. Part A. Y equals 3x minus 3, 2x plus 2. In order to find our x-intercepts, we can make y equals 0 or just use the null factor law. So x equals 1 and x equals negative 1. Our y-intercept is found by making x equal to 0, so negative 3 times 2 equals negative 6. The turning point is halfway between our x-axis intercepts, so add them together and divide by 2. This gives us 0. That's the x value, but we also need the y value, so negative 3 times 2 is equal to negative 6. Our turning point and our y-intercept is the same spot. To graph this, we plot our x-axis intercepts and our turning point, and we sketch. Because the equations after not only your graph, but also the intercepts and the turning point, you have to box all of these in order to get full marks. So you'll get marks for your intercepts or x-intercepts, you'll get marks for your y-intercept, for your turning point, and for your graph. One for each of these. Part B. Y equals x minus 3 all squared. To find our x-intercepts, we use the null factor, and we find out that x equals 3, i.e. there is only one x-intercept. Our y-intercept, making x equal to 0, squaring negative 3, we get 9. Our turning point is in fact our x-intercept at 3, 0. When we graph this, we plot the point for our y-intercept at 9, our turning point and x-intercept at 3, using the fact that it's symmetric about the line x equals 3, we can have a third point at 6, 9. Boxing all of our solutions, x equals to 3, y equals to 9, and 3, 0, we'll get 1 mark for each of these answers and 1 mark for our graph. Part C. Y equals negative 3x squared minus 4x plus 3. In order to do this, we are going to complete the square. So we pull negative 3 out as a common factor because we can't have an a value, not 1. And we complete the square. So we are going to plus and minus half of b, where b is negative 4 on 3. So negative 4 on 3, half of that is negative 4 on 6, which we square, plus it, minus it. We're going to take our first 3 terms of x squared minus 4/3 x, plus negative 4 on 6 squared, and factorize this. When we factorize this, we'll get x minus 2/3 all squared, and our last 2 terms don't change. So we will have 16 on 36 minus 36 on 36. I've squared the 4, squared the 6, and converted the 1 to a fraction with the same denominator. Expanding that negative 3 into this, I will get negative 52 on 36 and times it by negative 3, giving me an answer of negative 3 x minus 2/3 squared plus 52 on 12. Simplifying that fraction to 13 on 3. Our x-intercepts are found by solving that complete the square. So moving the 13 on 3 across and dividing by 3 gives us the 9 here. Then taking the square root of this, so root 13 on 3, and plussing 2/3 to both sides. That's my x-intercepts. My y-intercepts. My y-intercepts can be read straight off my original equation, with my c value being my y-intercept. The last is my turning point. I've already converted my equation into turning point form, which means that when I go to find my turning point, I can read it straight off this as 2/3 13/3. Now, in order to graph this, in my calculator, I get an approximate for 2 minus root 13/3 and for 2 plus root 13/3, and I can plot those 2 points. I can plot my y-intercept at 3 and a point for my turning point at 2/3 13/3. Connect the dots into a parabola and it's graphed. There's 5 marks allocated to this. 1 mark will be for a method to factorize. So the method I've used is completing a square. You'll have 1 mark for your x-intercepts, y-intercepts, turning point, and graph.